All right, folks, hopefully you had a nice weekend. This is our last section of these notes, so I'm gonna have you try the first one, and then I want you to tell me in your brain, telepathically somehow, why you think this one's gonna be a little bit harder. So just try it for a second, and I'll run through it with you. All right, so hopefully you figured out that your u would have to be, sorry, x minus 3. The problem is that du is 1, but this is x. So how do we get the dx part? Well, what you can do is actually solve for x. I don't know why this keeps happening. Sorry, my screen keeps pausing. Okay, so if I solve for x, I get u plus 3 equals x. So what you want to do then is literally substitute that in for x as well. So we're going to find the integral of x, which is really u plus 3, times u to the 1/2, right, because it's the square root, times du. And du is just 1, so that part doesn't really matter as much. However, what I would do is then simplify this a little bit. So this is kind of an extended kind of question, because you have to think about, oh, before I integrate this, I need to find out what x is so I can substitute back in and then distribute. So this becomes u to the 3/2 plus 3 u to the 1/2 du, right? And then once you integrate that, that becomes u to the, come on, doesn't like me right now, darn it. I'm gonna use lavender, maybe, if I can actually write. Yeah, what is happening? Really? U to the 5/2. I don't know what is going on with this thing. Times 2/5, right? Because you're dividing by 5/2, which is like times 2/5, plus u to the 3/2 times 2/3, but there's a 3 in front. So 2/3 times 3, the 3's are going to cancel, plus c. Okay, so you end up with 2/5 x minus 3 to the 5/2 plus 2 times x minus 3 to the 3/2 plus c. You can either do that, or if you wanted to factor it out a little bit more, you can, but this is fine for now. Okay? Usually we're used to factoring out. All right, try the next one. If you were to, just as a heads up, if you were to factor this out, the factored out version of this ends up being 2/5. I don't know what's happening. Maybe I'm just writing on my, sorry guys. Okay, anyway, it'd be 2/5. You can factor out an x minus 3 to the 3/2. And then you could factor it, so turn it into x minus 3 to the 2/2, which is really like to the first power. Because remember, if you raise this to the first power, that's like 2/2, so that's to the 5/2. And then you could do plus, to get a 2 there, you'd have to do a plus 5, right? Because if you do 5 times 2/5, that gives you 2. And then plus c. So technically, a way that we're more used to, I guess I need to figure out how I can write this a little easier. Sorry guys. 2/5 x minus 3 to the 3/2 times x plus 2, because you can combine these together, plus c. So it doesn't look that much cleaner, hence why you can leave it like that if you really want to. Anyway, try the next one, pause the video, and when you're done you can see what I have. Alrighty folks, hopefully you figured that one out. If you forgot the negative, unfortunately that is kind of a big deal because this becomes -1. So you have to factor out a negative. You also have to solve for x, which means it's going to be that quantity squared, because it's like x squared, right? When you expand it all out, because you have to FOIL this part, you end up with this, which then you have to integrate, plug u back in, and you get that. So feel free to look at my work if you need some more clarification. Just stop in. A slightly better version of this would be to factor out that 2 minus x to the 3/2, but I'm not going to hold you to that right now. This would be. Alrighty, so this next one, I'm going to have you take a look at it, see if you can figure out what to start with. These are a little bit more complicated because you have to think about what you're evaluating and then solve for that variable again. I don't know how these got on here. We're going to erase that. But again, rewrite it if you need to, so you can integrate x squared plus 2, 3x plus 1 to the -1/2 dx, and then think about your u, right? So your u is going to be 3x plus 1. Your du has to be 3, which there's no 3 by itself here. So I'm going to have to integrate a 1/3, because I have to take that 3 out. That's not present in the original equation. I'm going to have to solve for x, so I get u minus 1/3 equals x, okay? And then you substitute that back in. So what we end up with is u minus 1/3 squared plus 2, right? Because I'm substituting in for x. Then you have to multiply by, be careful because you don't need to substitute a whole lot there. Remember that this is u, so times u to the -1/2 du. Okay, so I'm going to have you pause the video for a second. Expand that out. Just don't forget about your 1/3 after you integrate. If you want to keep going, you can try that. But once you're done pausing, I'll have expanded it so you can kind of check things out. All right, folks, feel free to check. This one is not the prettiest of problems, but again, if you want to simplify it a little, you could factor things out from the beginning before you plug u back in at this point if you want to. But you can also just leave your answer super gross looking. Honestly, if you factor something out, it doesn't get much prettier, so not the end of the world. The next one, slightly easier, which is cool, and then the last few are going to be the same, only because you can substitute in. So notice how your integral has changed a little bit. Now it's between two values. So again, you want to say u equals x cubed plus 1. Your du, nicely enough, is back to the standard 3x squared dx. So because there's a 3 and no 3 here, you have to factor it out. The 1/3 to cancel it. Again, you're integrating between 1 to 3, so make sure you keep that before you integrate. So in this case, you're going to have u to the 1/2 du. Integrate first, then plug in the values if you forgot that. That is a thing. So this would become 1/3 u to the 3/2 times 2/3. Okay, so that becomes, and then there's technically, I guess there is a plus c, but when we are integrating between 2 points, we don't care. So make sure that you're evaluating between 1 and 3 still. So that becomes 2/9 x cubed plus 1 to the 3/2 between 1 and 3. And if you need a refresher about what to do at this point, now you're plugging in 3 and 1, you subtract the values. So literally it becomes 2/9 3 cubed plus 1 to the 3/2 minus 2/9 1 cubed is 1 plus 1 to the 3/2. Feel free to plug that straight into your calculator if you want to, because 27 plus 1 to the 3/2 is not a pretty number. So pause it, plug it into a calc, unpause it, I'll have it checked for you. All right, folks, hopefully you got 32.3. If you did not, just be careful of order of operations and fractions and all that jazz. Oops. All right, we got 3 more. So I'm going to have you try the next 2. And then the last one I'm going to have to do with you because it's a little different than the other ones. But try the next 2 because they shouldn't be anything crazy for you. I'm just going to give you the answer for the first one, and then I'll go through the work on the second one because the first one you should be able to handle. It's very similar to one we already did on the previous question, so you should have it handy. We actually did this question basically. Now you're just integrating between the 2 points. So feel free to look back in your notes if you don't want to redo the integral on it. But pause the video. I'm going to give you the answer to the first one, and then I'll have the work for the second one. Sorry, folks. 16/3 is the answer to this question. The answer to the previous one was actually like 0.005. Some of you were like, what is she talking about? Sorry about that. I was looking at the wrong question. Anyway, if you need help with either of those, just let me know. But this last one we're going to just do together because they're asking you something different. They're asking you to use even and odd functions to help you evaluate this. And what that means is we're going to have to plug in 4 both parts basically. So sorry, that took me a second to think about. Okay, so even and odd functions just means that you have to integrate 2 parts. Thinking about the fact that technically if you go from 0 to 3, it should match if it's even the right side of the equation. So what we're going to do is plug in the same way we did. So u is going to be x squared plus 3 dx is, du is going to be 2x dx. So we end up with just u du. And what happens is if you integrate that, you get u squared over 2 between 0 and 3. Now, the thing is, we want to know if this is an even function, right? We want to wait until we can plug in back, because if it's even, what'll happen is the integral between 0 and 3 will be the same between -3 and 0, so you can literally just double your answer. If it's odd, it cancels out. Remember, it's a reflection, so your integral actually ends up being 0. But what we can do is plug in at this point. So I know it's going to be x squared plus 3 squared over 2 between 0 and 3. Now to check for symmetry, if you forgot about this rule, you plug in -x. So if I plug in -x here, if I end up with the same function back, I know it's an even function. So I get x squared plus 3 over 2 squared. Even. Even, which means if I get a number between 0 and 3, it'll be the same on the other side. If you imagine like a quadratic, the integral over here is going to be the same as over here. So you can just find the integral here and double it. So that's what we're going to do. We're going to take 2 times whatever I get for this part. So if I plug in, I get 3 squared plus 3 quantity squared over 2 minus 0 squared plus 3 squared over 2. So I'm going to take 2, I'm going to multiply it by what I get on the inside, which is 9 plus 3 squared, so 12 squared over 2 minus 9 over 2 because 3 squared. So you get 2 times 144 minus 9, so 135 over 2. Okay, and then you end up canceling the 2's. So what's nice is you end up with 135 as your area, basically, the integral. Remember, the area and integral are the same thing. So, well, I hope you learned a lot in this section. We are going to move on to some new stuff next week a little bit, but actually I'm just going to give you a rundown. Just a reminder to watch all your videos carefully. Next week we're going to start doing a little bit more on accuracy for those questions I throw into the video, so just be careful. Actually this week, so including this one. What you're going to have for homework is kind of a mixed bag of stuff as well, but I'll give you the answers to everything after that. And then we're going to review a little bit. We're going to start our next section, review a little more, and then we'll probably do some kind of quiz via like quizzes on Monday the 6th. And then we only have a few days before vacation, so please stop in to my office hours if you have questions, but otherwise I hope you have a wonderful rest of your day and make sure you do the textbook homework.